Welcome back once again to the mathematics session. In this class, we are going to discuss about the Vedic mathematics series. Okay, we were discussing the Vedic mathematics tricks and techniques since past few series, right? Those who have not watched them, just click on the I button, then you can be notified. Now, in the Vedic maths series, we have completed the additions, subtractions, multiplications, all the techniques, specific and the general techniques. Now we will switch over to the divisions part. In the divisions part, I'll start with Arthur Benjamin method. Okay, this method, this person Arthur Benjamin is a speed math specialist. He has developed this using the Vedic mathematics, right? He has worked on this types of divisions tricks using the Vedic mathematics. So this method is been named as the Arthur Benjamin method, right? Now let's get started. Now for divisions, I have taken a 5-digit number divided by a single digit numbers. Now we'll start with this. This is not any Arthur Benjamin method, but just we will be starting with the single digit, then to the double digit. Okay, now how do we do the single digit in a traditional way? We just put on two brackets and we do it, but we can do it in a shortcut method from left to right also. Let's start division with 4. This is a 5-digit number, so 4 divided by 4. So if I start, so 4 ones 4. From left we have to start in the Vedic maths, isn't it? So far 4 ones 4. 4 doesn't go with 1 because it is less, so we have to place a 0 and this should be carried over here. 1, so 13. So 4 how many times? So 4 3s 12. So 1 is the remaining, so that is carried over here, and 4 4s 16. Now nothing is remaining, so just 0. 0 is carried over. No need to place 0 also, and 4 2s are 8. So this is the final answer. Likewise, we will do another one taking 7. Okay, 7, will it go with 3? No, it is lesser number, so let us take 2 digits at a time. So 3 and 9, 39. So 7 5 35. So 4 is carried over. 7 6 42. So 2 is carried over here. The remainder we have to carry over. Now 26 will not go in 7, but 7 4 is 28. 7 3 is 21. Isn't it? 21. 5 is remaining. So place a decimal point. So we'll carry over 5. When you take a decimal point, 0 is naturally there, isn't it? Right. Now 7 how many times? 7 7s 49. So 1 is carried over. Again, if you place a decimal point, 1 0 at a time can be taken, isn't it? So 1 and 0. So 7 ones 7. Again 3 is there. 0. 3 and 0. 7 4 is 28. But let's stop for taking decimal after 2 digits. It goes on, right? Isn't it? So if decimal point comes, nothing, just place a decimal point and a 0 as we do in the traditional way. So with the single digit numbers, we go likewise. In only one step, we get the answer. Now if you take a double digit number, I want to divide a double digit number. Let me take 7432 divided by 28. Let me take a double digit number, 28. Right. Now let's start this one. Here we have to place 28. Now let me write 7432. This is the Arthur Benjamin method. He is a speed math specialist. He has developed this, isn't it? Right. Okay. Now the last digit in the number will give us the remainder. So we will place a line here so that the remainder which comes here will be easily notified. So now we have to place for one last digit a line. Now let's take this. Here 28. It is near to, we have to round the 28 to the nearest possible number. So 28 is near to 30, isn't it? Right. Now we have to remove this 0 for some time. Remove this 0. That means for 28, how many numbers should be added to get 30? So we need to add two numbers, isn't it? Plus 2 if you do, you get 30. For 28, the nearest round up number is 30. So we need to add plus 2. Right. Now, here in the process of division, I will be dividing with 3, but indirectly it will be divided with 28. How does it work out? I'll tell you. Now, the first digit as it is, drop at 7. Okay. 7 as it is, we will drop the first digit. Now, here, this first digit, in how many times it goes with the 3? We should remove the 0. We have to take only 3. 3, how many times it goes for 7? So, 3 twice 6, isn't it? So, 1 is remaining, that you place here. Now, when you are writing this, this should be multiplied with the complement. This complement is lesser to the round up number. So, that every time after getting this, you have to multiply with the complement. 7, 2 2s are 4. So, that is plus 4. So, add them. This 14 plus 4, it gives you 18. Isn't it? Now, this 18, how many times it goes with 3? Always you have to multiply with 3. Getting some number, that should be multiplied with the complement. That's all. And carried over to the next number. So, 3, how many times? 3, 6, 18. It goes perfectly. So, nothing is remains, so 0. And this 6 should be multiplied to the complement. 6 2s are 12. Right. Now, how much? 3 plus 12, it comes to 15. Right. It nearly comes to 15. Now, 15, how many times it goes with 3? 3 5s, 15. So, it goes perfectly. Nothing is remained. So, 0 is carried over here. And 5 should be multiplied with 3, the complement. 5 2s are 10. Right. Here. 10 plus 2 is 12. So, this part, when we have divided it, this place, here we get the remainder. This is the remainder. And whereas this is the quotient, right? 265 is the quotient and 12 is the remainder. To get the remainder, to get it notified, we have to place a line here so that this part will be giving us the remainder. Right. Now here, if you want to proceed, if you want to get this number, not only remainder and the quotient, but if you want to get it in the decimal points, place a point and further continue. Okay. Place a point here. Now 3, how many times 12? 3 4s are 12, isn't it? So you can get it. So 0 you'll get, again 0. So you can write it as 265.4 is the decimal form of 743 divided by 28, or else take this as remainder and this 265 as a quotient. Hope you have understood this. Quickly make a note and let's start this. Again 5-digit number with 89 with a 2-digit number. So we'll write it here. So 87435. So the last number we will use it for the remainder part. Okay. So I have placed a line here. Now here this 89 is when you round it up, it is nearing to 90. Okay. So that means how much we need to add for 89? We need to add plus 1. If you do, you get 90. So just remove the 0 and we will be multiplying with 9. Indirectly we will be multiplying with 89. Okay. Now let's take the first one. As it is, you have to drop it down 8. Isn't it? Right. And here 9, how much are 8? Because 8 is lesser than 9, we have to take, when in the traditional division method also, if the number is less, we will be taking it the next number also. So this is less, so we need to take the next number 7 also here, 87. Now 9, how much are 87? 9 9s 81. So 6 is remained, so that I will carry over here. And this 9 should be multiplied to the complement. This is plus 1 complement here. So 9 1s 9. So place it here. So if you add 64 and 9, it comes to 73. And how much? 9, how much is 73? So 9 8s 72. So 1 is carried over here. Right. 8 into 1 complement, that comes to 8 here. 13 plus 8 comes to 21. Right. Now 9, how much is 21? 9 2s are 18. Okay, because 9 3s it won't come. So 9 2s 18. So 3 is carried over here, and 2 into complement 1 is 2. So we get 37 here. So this is the remainder part, whereas 982 is the quotient. Now if you want to get it as here, how much you got? 13 plus 8 is 21. So 9 2s are 18, right? So 35, right, 37. Now if you want to get it for the decimal, keep a decimal point. Now 37, how many times it goes? 9 4s 36, isn't it? So 1 is carried over. Obviously when a decimal point is there, you can take 0. So 9, so that will be carried. 4 into 1 is again 4. So if you take 14, you get here. So 14, 9 ones 9. So likewise, you can stop it after 2 digits. So the answer will be 982.41 if you take it in the decimal form, or else 982 as a quotient and just 37 here. This position is our remainder. 37 is the remainder. This method you can easily find out. For the illustration only I am doing it very slow. Okay, you can do it very fast. Now let's do the next. Now we'll see the next problem here. There is a variation here. I'll tell you the variation. Now 6 5 4 3 2 as it is I've written. The last number will be taken for the remainder part. So 31. Now the variation here is that the rounding number for 31 is 30, isn't it? Right? 30. But to get 30, how much we have to add here? So if you add any number, it will be more than 30. So already it is 31. So we need to subtract. That is the variation here. So how much we need to subtract here to get the round off number? So minus 1. So all the while we have done in the third and the fourth problems with plus 1, because to get the round off number we were adding. Now here to get the round off number we are subtracting. So that is the variation. Now here the 0, just ignore it for some time. 3 you have to take it. Now let us drop this number as it is, 6, and here. Now 6. We have to multiply and see 3 how many times 6? 3 twice 6. Isn't it? So how much? There is nothing. So we nothing to carry, but we can also place it as 0. Now 2 into minus 1 you have to do. So 2 into minus 1 is minus 2. So here 5 minus 2 is 3. Right. Now here 3 how many times it goes? 3 once 3. No, nothing is placed. So 0 you can place. And 1 into minus 1 comes to minus 1. 1 into minus 1, minus 1. So 4 minus 1 is, you get it as 3, isn't it? So just when we are multiplying with the complement, it is minus 1. So that you need to take caution. Okay. So 3 how many times? 3 once 3. Right. So nothing is remained. So 0. So again 1 into minus 1 is minus 1. So 3 minus 1 comes to 2. Okay. How many times 2 will go with 3? Because it is lesser, it can't go. So let us take 3 0 times. Okay. We take 0 and 2 will be carried over here. Right. Now 0 into minus 1, again 0 you get. And here 22 minus 0. So 22 plus 0 or minus 0 here. Isn't it? So that comes to just 22 here. So this is the final remainder. Okay. This is the, so how many times? 3. This is 22. So 3. You can stop here. This is the remainder and the quotient. But if you wanted to get it in the decimal part, so keep a decimal point. So 3 7s 21. So 1 is carried over here. Obviously for decimal point you can take 0. Isn't it? Right. Now 10. It comes to 10. 7 into minus 1 is minus 7. So that comes to here. If you do, that comes to 3 here. Right. And we can continue. That 3 you can drop it here. So 3 how many times it goes? 3 once 3. So we can stop it till here because we have taken it for 2 decimal points. So this is the final answer. If you stop it here, 22 is the remainder and 211 here. Remainder is 22 and the quotient is 2110. Or else if you take it in the decimal part, you can continue for 2 digits. Now let's start with the next one. Now 43 here, 58936. And the last one I will draw a line here. Now 43 nearing to which number it will be? Round off. So nearing to 40 you can take. So that means if you subtract minus 3 only, we get the round off number. So minus 3 is the complement here. Right. Ignore the 0 for some time. Now drop the 5 as it is here. Okay. Now here 4, how many times it goes? 4 ones are 4. So 1 is carried over here. And 1 should be multiplied with minus 3. 1 into minus 3 is minus 3. So 18 minus 3 is 15. Okay, 4 how many times 15? 4 3s are 12. So 3 is carried over here and 3 should be multiplied with the complement. 3 into minus 3 is minus 9. So 39 minus 9 comes to 30. Right. 4 3s 12. Okay. So 3 is carried over here and do not forget to multiply with the complement. 3 into minus 3. 3 3s are 9 minus 9. So 39 minus 9, 30 it comes. Now 4 how many times 30? So 4 7's 28. So 2 is carried over here. 7 should be multiplied with the complement. 7 into minus 3 is minus 21. Okay, 7 3s are 21. So if you subtract 23 minus 21, you get it as 2. So will 2 go with 4? No. So we have to place a 0 here. Right. So 2 is carried over here. Now 0 into minus 3 is 0 again. So you get 26. This 26 is the remainder. And this is the quotient part. Now we will see the decimal part of this. So place a decimal here. So this 26, 4 how many times? 4 7's 28. So let us take 4 6. 4 6 are 24. So 2 is carried over. Obviously we have a 0 after decimal. So 20. Now 6 how many times? 6 minus 3 is so minus 18. 6 3 is 18. So minus 18. So 20 minus 18 you get it as 2. Okay. Will 2 go with the 4? No. So place a 0 and will be carried over again to 0 likewise. It goes on. So the answer will be 1370.60 in the when it is taken as decimal part. And if you consider the quotient and the remainder, you can stop it here. Right. This part gives us the quotient and this part gives us the remainder. So I have told you a variation for the negative complements. Okay. When the round off number is some numbers less, so we write minus. When the round off number is more, so we write the plus. So this is called as the Arthur Benjamin method of he has used the Vedic mathematics principles and deduced this method. Hope you have understood this technique and we will see, just note it down, we will see in our next video with a new technique. Thank you all.